Hi, and good morning, and welcome to the ZP Developer Zone. So every Thursday at 8 a.m. London time, we do a specific webinar for our ZP Developer Zone members. So hopefully this is coming through sort of clear enough, but I was essentially jump straight into it. So I always put this slide up every week, and it just kind of gives you a highlight and overview of essentially some of the free community work or community services that ZP has. We have our ZP Academy. Here you will find free courses. We have this webinar, at least we do one webinar every week at 8 a.m. London time. I just want to say hello to Aftab. It's nice to see you this morning. We also have our collaborations. With collaborations, we do them academic collaborations. We also have obviously collaborations with our ZP Developer Zone members as well. We also, on the job front, it's probably worth saying that we are advertising a new PhD with the University of Wolverhampton pretty soon. Not Wolverhampton, sorry, my apologies. University of Warwick. So that should be quite interesting. We have our ZP Developer Zone, which is essentially a website where we allow people to ask questions and then we answer them through this kind of webinar. And finally, we do have workshops as well. So the next sort of slide then is every week we do answer questions, and so the kind of questions that we have this week, we have a question on discussion of microneedles, and the microneedles that we're discussing are, I'm going to discuss solid microneedles. The questioner is really asking about hollow microneedles, so I will discuss hollow microneedles as well. We have one questioner asking about custom screen printed electrodes, and we will discuss that. I'm sorry for the background noise. I'm actually in a different location this week. So normally I do this from the UK, but this week I happen to be in Norway, and question number 3 was about really pH contact electrodes, and I'll discuss that. And also then question 4 was about biosensors on screen printed electrodes. I might just ask Aftab that because I'm on a different setup this week, whether the volume is coming in through okay, but hopefully it is. So question number 1, right? Somebody wants to purchase hollow microneedles. So I'll just give you a kind of quick backstory on that. At Zimmer & Peacock, we have, arrays of solid microneedles. By the way, if I use a link, I will definitely put the link under the video below. So it's nice that the questioner has come to us because we do have a range of solid microneedles. This is one of them. We've actually got something that's quite new as well. This is a new, let's say, microneedle patch. With these microneedle patches, we're metallizing them and putting like gold and platinum onto them, and we're also leaving them bare. And with those patches, we do have essentially the dimensions on the website, so you can dig into that and kind of have a look at all the various dimensions on those. Now, the questioner was definitely asking about hollow microneedles, and so everything I've just talked about was actually solid microneedles. Cool. It's good to see Hitcham as well. He's here as well, so thank you, Hitcham, and thank you for confirming after you can hear me. Cool. Now the reason I've brought this image up is because I realized we didn't have any hollow microneedles at ZP, and I thought, okay, well, we'll go and develop them. And the first thing I noticed was then actually that they aren't actually available online. So the reason I brought this up is because if people are interested in doing hollow microneedles for things like drug delivery, then those kind of technologies, they definitely exist actually. I mean, this technology I think is for using, I think the sort of street name for it is Botox treatment, where you treat people's skin with a sort of toxin from botulism, I think, and it helps iron out wrinkles. So the inquirer is asking us about microneedles. Now, if you want microneedles for biosensing, I agree, those are not commercially available, and ZP could develop those. If you're interested in microneedles for essentially delivering drugs and vaccines. I think they really do actually exist now. So I think it's careful, at ZP, it's always important to kind of, not reinvent the wheel. So if the questioner is interested in hollow microneedles for, really for doing biosensing, yep, we can work on that. If it's for doing drug delivery, then I'm feeling that, this kind of technology is already, let's say, done. Now, this is an interesting one for me because we do get a lot of people who come to us asking us for custom screen printed electrodes, and they want them according to their specifications. And, the kind of specifications, they'll ask you for the length, they'll ask you for the width, which is cool. They'll ask you for the thickness of the electrode. They'll ask you for the print thickness. So, when you print that carbon or that platinum, is it 25 microns, plus or minus some specification. So, that's all very good. Now, the problem with that is, if you're going to use electrodes for doing electrochemistry, there's at least two other parameters that are not necessarily covered. One of them would be roughness. So, if you zoom in on that electrode, you can control the length and you control the width, it's fine. But then if you actually look at it, from a profile perspective, obviously there's a certain roughness to it. And it can be very subtle, that roughness. Controlling roughness is it's partly from the ink itself, it's partly from the mesh, it's partly from the print speed, it's partly from the mesh diameter, and it's partly from the drying, the mode of drying, the time of drying, the energy that you use, let's say, per second in drying. There's many parameters that actually affect the roughness. Now at ZP we do have profilometers, so we can actually measure that. Now there's at least another, as I said, people are very interested in the physical dimensions, but obviously they don't necessarily talk about some of these more microscopic parameters. And there's also the electrical properties, which is, what's the resistance on the various tracks that you're trying to measure. If you're doing, whether this resistance is important or not, depends really on what you're trying to do. So if you're trying to do voltammetry, the resistance could be, more significant, can be more of an issue. If you're trying to do amperometry, the resistance can end up suppressing your signal, but it might not be too much of a problem. If you're trying to do potentiometry, then these resistances might be insignificant relative to the resistance of the instrument itself. So whether resistance is important or not it's probably a consultative discussion with ZP, because it's important when giving specification to actually say, are these specifications just something that I really think are important, or are they actually important? So we're happy to receive inquiries about doing, let's say, custom screen printed electrodes, but often it's just like, these are my dimensions, can you make this? Yeah, sure, we can make it, but is it really, have you really got it fully spec'd? At least roughness and at least resistance. Now at ZP we do something a little bit, I would say, unusual, that we do functionally test. Now Aftab and Hitcham, the guys who come here and talk, I've spoken to a lot, they know this, verbatim, but at ZP we do something quite different. We actually functionally test electrodes for clients in the way they're actually going to be used. So it could be an amperometric test, it could be a potentiometric test, it could be a voltammetric test, or it could be something like an impedance test. And we call that basically wafer mapping. So we'll take sensors from various parts of the batch, beginning, middle, and end, and essentially check sheets of sensors and make sure that they're actually within some sort of functional spec. The reason I bring up functional spec is functional spec really contains all of the information. So it will really tell you whether the working electrode dimensions are in spec, combined with is the roughness correct, combined with the fact is the resistance correct. So everything else is superfluous. It's really the functional test that's important. Because in some ways you can have the same kind of functionality with a smaller electrode that's rough. Or you can have the same functionality with a larger electrode that was smooth. There I'm just playing with the idea of surface area. So I'm saying it's really the functional testing that's really important. Now at ZP we obviously do the manufacturing, we then do the OQC, and then we pass the data to Julie. And this is Julie's cool because I will basically give you a quick demo on Julie at the moment in a minute. But let me sort of give you a sense of Julie. So this is the Julie database. It is free to open up these accounts on Julie. You know, AFTAB and HitCham, they know this, but you know, Julie is a good tool for uploading data, sharing data, analyzing data. So at ZP, we could manufacture for ourselves or manufacture for third parties, test them, upload the data, at which point then it's, what we can then do then is, what I've done now is I'm going to just go into Julie. I can see the raw data has been uploaded. So I can see the files, let's say. I can then see properties. So I can see that this is a discrete measurement because it's a voltammetric measurement in this case. And I can also do then analysis on it. So what we've done here is we've set a window. So what I'll do is if I close that for a second, we've set a window and said, analyze the peak height at 0.3 volts and look at from 0.2 to 0.4. So we've defined that window. So we've kind of, for me, we can analyze the production in a way that you actually use the sensors in the final assay. So it makes the testing equivalent to the way the sensor will actually be used, or the electrode will actually be used. The reason I say that's important is because if you just measure resistance, then yeah, you might hit the resistance, let's say, specification, but it didn't tell you anything about whether you were able to then use that electrode, you know, necessarily in your voltammetry. So if I just go back to tools again, I mean, Julie allows us to, you know, essentially upload the data. Then we can do analysis of the data, and we can do things like define what we're going to analyze, the window around that analysis. We can modify those things if we so wish. At which point then Julie automatically does the analysis, and it gives us a sense of you know, our minimum, maximum, our median, our relative standard deviation, our standard deviation, our mean. So it gives you the statistical results, and you could also export that as a PDF, download the results, etc. So the reason I went through all that is the inquirer is asking about custom screen printed electrodes. These often come in, they're very mechanically defined. They don't necessarily then talk about some material properties, which would be like roughness and resistance. And then they definitely don't discuss functional properties. And ZP is very different, that we can functionally test the electrodes in the way that they're meant to be used and upload the data. And by the way, AFTAB, HitCham know this, but this Julie database is, you can basically open an account, no real issue. So I just did a quick demo on that. So the Julie, if used in quality control, allows you to define the operator, define the date. You can get the data up there, you can do the analysis up there, and then it will prevent whoever is manufacturing sending you stuff that's basically out of spec. Now, it's also worth saying that there's a big, my first advice is, if you're going to do due diligence on somebody to manufacture your screen printed electrodes, before you get into a whole conversation about whether they can do what you need them to do, just buy something they have off the shelf and test it. You'll be very surprised by some of the variability that is coming from manufacturers. So my advice is, we do have a whole article on what's wrong with really screen printed electrodes, and we do have, my advice will be, to essentially purchase a hyper value screen printed electrode from ZP and just test them. We did have another inquiry, it's question 3, which was about contact pH. Somebody wants to measure not so much a liquid, but really the pH of a surface. And I'm really, really pleased with this inquiry because, or happy to have this inquiry, let's say, because, traditional pH probes, we can all imagine them in the lab sitting in a, beaker of pH, a pH buffer rather, that form factor of glass doesn't allow you to sort of put that pH sensor onto a surface and measure the pH of a surface. Whereas our screen printed pH sensors, in this case I'm recommending the hyper value pH sensors because the cost is really of sort of to most commercial entities, the cost is really a nothing in this particular case. We do have some technology that I think will be even better in the long run because it actually contains 9 pH sensors. So you can do a lot of data science on 9 pH sensors. That's there. The only one issue with that one is then you have to have an instrument able to read 9 pH sensors. We have some prototypes, but we don't have it, we haven't commercially released it. So my advice is if you're trying to measure the surface pH, I mean, one example would be actually, it sounds ridiculous, measuring the pH of cheese. We have played with the idea of measuring the pH of cheese. We've also measured the pH of dough during baking. So these sensors kind of work in applications where the sample might be damp, but it's not liquid. Anyway, in this case, I think the particular inquirer has what we call an anapot EIS. You can check whether you have an anapot EIS by looking on the backside. If you see 5 pins there, that's the anapot EIS. This inquirer, I actually know they have this cable because I delivered it. So I think they have an anapot cable. It should have 5 prongs in here. Then you've got the right cable. What they need is a 7mm connector so that they can make good electrical connection with those sensors. And I also just want to kind of highlight that actually, if you want to make a low-cost pH instrument, we do have some nice OEM solutions on it as well. Now, question number 4 is from an academic group in Europe, I believe, and they want to, in their question, they have, do you make biosensors on screen-printed electrodes? We do. But then the reason I brought it to this forum is because we can talk about calibration, and they then want to calibrate it. So the quick answer is, all of our biosensors on our website are on screen-printed electrodes. So the glucose, the oxygen, the lactate. I'm not going to read all the list, but these are all on screen-printed electrodes. You can check by just clicking the buttons, and you'll see either images or data sheets regarding this. Now, in order to do calibration, we essentially go into the lab, and here we've got signal versus time, and we keep increasing essentially the analyte and the signal changes. So this is kind of how we would do a calibration on it. So we would do that calibration. We actually do sell calibration solutions at ZP. You can obviously try and make up your own solutions, but we do sell calibration solutions which are more useful for commercial entities, universities, obviously, save the time and do it yourself. Now, the reason I've got Julie up here is because the way we calibrate then, now the reason I brought an image of myself is if we do calibration for people, that's using, an engineering firm to do it. That is an expensive procedure for ZP to do calibration. If you're in academia, then the lowest cost option is actually to calibrate, let's say, yourself. But I just want to show you how Julie, we talked about Julie once today because we use it as an analysis tool for quality analysis. And that means that we can upload the data, analyze the data, and then share the data straight off to the client. In this case, the academic would get themselves a Julie account. I've got Julie open here. Here we've got a different type of data. I can see the files, so I've uploaded the files. If I look under properties, this data, I'm calling it continuous. It's because it's for a glucose sensor, and it's continuously measuring, and then we periodically change the glucose concentration. And then what we're doing is we have something here, a configuration concentration, it says. What this allows us to do, it allows us to say, here's my raw signal. Now in here I've got lots of glucose sensors, but what it allows us to do is go in there and tell the software at time is equal to 2,500 seconds, the concentration was 0. At time was equal to 2,700, I can change that slightly if I want. Then the concentration was 4 millimolar in this case. At time was equal to 2,900, the concentration was 8 millimolar. So I can basically go along here telling it what concentration. AFTAB, my apologies. I actually missed the fact that somebody had posted a question in the forum, so I apologize for that, AFTAB. So yeah, if you post it, I'll try and answer it in real time. So all I'm saying here is ZP can calibrate these sensors. ZP is an engineering firm. I think it's actually lower cost if you're in academia to do the calibration yourselves. You can buy the sensors, you can buy the calibration solutions. You can do the experiment, which is where you really save the money, let's say, because you use your own time. And then you can actually use Julie, which is free, to upload your data and then analyze your data. And at which point then, Julie, now this is data from several sensors. So at this point now, Julie will give me that my coefficient here is actually minus 3.04. Sorry, when I say my coefficient, my intercept is minus 3.04. My gradient is 69. I've got here, these are R&D sensors. There's one that's really out of family. You can see that we've got a whole bunch here, but one's out of family. But you could do this on an individual level, which would, you could do it sensor by sensor. Here we're doing some R&D and we're doing it lot. I just want to say, right. So the reason I brought that up is because ZP does make screen printed electrodes. We turn them into biosensors. We calibrate them for, let's say, industrial clients. I think for academics, I think it's get the calibration solutions, do the calibration yourself, use Julie, and then you can actually do essentially the calibration, like I say, and it'll be a lower cost for you. I'm just checking. I'm just reading something very quickly here. My project is, so we got a question that came through on the chat, which is my project is to develop a point of care testing platform for performing immunoassays. Yep, that's fine. In serum and urine of pregnant women. The concentration levels are in 1 to 1,000 picograms per mil. Yeah, okay. So I'm going to very quickly answer that question. So what I'm going to do is I'm just going to pull in this very quickly. I'm going to Google something which is beautiful gold electrode Zimmer and Peacock. So we have a slide here, and in this slide, now this person wants 1 picogram to 1,000 picograms. So 1,000 picograms is about 1 nanogram. So the starting, so this is some data. This data is actually, obviously at higher concentration, so I'm not denying that. But my advice is, if you're trying to make an immunosensor, the place to start for me is one of the ZP gold electrodes, this 303s here. The reason really is the quality. We were talking earlier on about, if ZP is going to do a custom job for somebody, then we will do functional testing. I also showed you that the power of Julie. So all of the if we make gold electrodes for somebody, we will, or rather, when we make gold electrodes, we've tested them for repeatability, so it's a really good platform to build upon. So the quick answer is we make lots of immunosensors for clients, and if we do it on top of these gold 303 electrodes. They are exceptionally really high quality. So I'm just going to go back to the questions and say, we had a discussion on microneedles. ZP has a lot of solid microneedles. The inquirer wants hollow microneedles. If you want hollow microneedles and you're doing, let's say, viral and vaccine injection or drug injection, then I actually think those technologies already exist. If you're doing it for biosensing development, let me know and we can discuss that. Custom screen printed electrodes. I just advise anyone who's after custom screen printed electrodes, in your spec, you have to talk about functional testing, because if you're not functionally testing, you can get something that looks perfect, but it could look perfect by eye. They could even be within your mechanical definitions, but the material properties like roughness and resistance could be terrible. If you want to know whether it's going to function correctly, do a functional test, and Julie gives us a really unique tool that we could do that functional testing, upload the data, you can see the data, you can make an immediate quality report from the Julie. pH contact electrodes, yeah, we do have a ZP hypervalue pH sensor, and the particular inquirer, I'm pretty sure that they have actually a cable, but they will need the 7mm connector to get really good connection. Question number 4 was about, do we make biosensors and screen printed electrodes? I think we actually have the world's widest range on that particular case. There's calibration solutions available on the ZP website, and the Julie database will allow you to actually do almost automatic calibration. Just go in the lab, test it at a few concentrations, upload the data to Julie, tell Julie that at this time the concentration was this, at this time the concentration was this, at this time the concentration was this, and then Julie will do all the maths essentially for you. And then I'm just reading some questions here. Yes, right. And the last question then is really coming from was coming from AFTAB. It's a question number 5. If you're trying to make a immunosensor, then the gold electrodes are pretty good. I'm just reading Santosh's comments here, and we often tether the gold onto the gold electrodes. We tether the antibody for the immunosensor using sort of thiol chemistry, and we have discussed that, but if that needs to be rediscussed, we can do that. So I am going to say, I'm going to check the time first of all, yeah. I am going to say thank you. The video quality wasn't as good this week because I'm coming off my laptop, but it was nice of AFTAB to confirm that the sound quality was good, and I appreciate it. So if I didn't answer your question this week, it's probably I missed it this week, but start putting the questions into the forum on the ZP developer zone, and then maybe I'll pick them up there. Okay, thank you very much, and speak soon. Cheers, guys. Take care.